Hello students, in this video we will learn about nature of roots of a quadratic equation. Okay, so we know that the quadratic formula for the roots of a quadratic equation is this: x is equals to minus b plus minus square root of b square minus 4ac by 2a. Okay, so now to determine the nature of roots, the nature of roots of a quadratic equation depends upon this term which is inside the square root. Under the square root, let us call it as d. This is b square minus 4ac. Okay. Now, if this d is positive, then the quadratic equation has two distinct and real roots. Now, if this d is equals to 0, then the quadratic equation has two, then it has real and equal roots. And if d is less than 0, then the quadratic equation has no real roots. There are no real roots for this quadratic equation. Okay, so the kind of roots the quadratic equation will have will depend upon this discriminant. This d is also called discriminant. Okay, and let's take one example to find out whether a quadratic equation has real roots or not based on this formula. Okay, so let's consider the quadratic equation square minus 4x plus 3 is equals to 0. Now here a is 2, b is minus 4 and c is 3. Okay, so now your d is b square minus 4ac, which is 16 minus 4 into 2 into 3, which is 16 minus 24, which is minus 8, which is less than 0. Therefore, this equation does not have real roots. Okay. So now let's take another example, which is 3x square minus 2x plus 1 by 3 is equals to 0. Okay. So now here it is a is 3, b is minus 2 and c is 1 by 3. All right. So d is b square minus 4ac, which is 4 minus 4 into 3 into 1 by 3. Okay, so this is 4 minus 3 gets cancelled in numerator and denominator. So this becomes 0. Therefore, this equation has real and equal roots. And now you can also use the quadratic formula to solve this quadratic equation. All right. So Till now, we have learned about nature of roots, and now let's try to understand geometrically about the nature of roots. Okay. So when we talk about the zeros of a polynomial or roots of a equation, okay, zeros and zero of a polynomial, let's understand this concept. Zero of a polynomial is same as root of an equation. Okay. Now what is zero of a polynomial? Zero of a polynomial is that value of x which makes the polynomial zero, and root of an equation is that value of x that satisfies the equation. And when we talk about the quadratic equation, we have 0 on the right hand side. So that is why 0 of a polynomial is same as root of a equation. So now what is the geometrical meaning of the zeros of polynomial or quadratic roots of a quadratic equation? Now if we talk about, say, a graph of quadratic polynomial. Okay. So it's generally a parabola. Now this can be an upward parabola or a downward parabola. Okay. Now that depends whether A is positive or A is negative. Okay. So when we talk about graph of a quadratic polynomial, it is either an upward parabola or a downward parabola depending upon whether A is positive or A is negative. Okay. So when we talk, let's talk about a simple graph. Suppose the graph of this given quadratic polynomial is this. Okay. Now this is x1, this is x2. Now this polynomial intersects x-axis at 2 points. So at this point, the value of this polynomial, suppose if the polynomial was ax square plus bx plus c, okay. Now if I substitute x as x1, then ax1 square plus bx1 plus c, the value here is 0. So therefore, this x1 is a root of the quadratic equation, or x1 is a 0 of the quadratic polynomial. Okay. So there are two distinct and real roots. Now, what if parabola is of this form? It intersects the x-axis only at one point, say alpha. Okay. So now at alpha x square, the value of the polynomial is 0. So therefore, this has to be a alpha square plus b alpha plus c is equals to 0. So therefore, the value of the polynomial becomes 0 at this axis equals to alpha. So therefore, this alpha is a 0 of a polynomial, or it is a root of this quadratic equation ax square plus bx plus c equals to 0. Okay. So now this parabola can also be of the form like this. Now this parabola never intersects x-axis this axis, which is the x-axis. So therefore, there are no real roots for this. There might be some complex roots, but there are no real roots. Okay. And note that in all of these parabolas, a is greater than 0. That is why it is an upward parabola. Okay. So, no real roots. No real roots means d is less than 0. Discriminant is less than 0. And here d was equal to 0. That is why we had equal roots. Okay. So there has to be only one root, but that will be a repeated root. Okay. And here d was greater than 0. That is why we had two distinct and real roots. So the parabola was intersecting the x-axis at two distinct points. Okay. And now, what if your a is less than 0? Okay. If a is less than 0, these parabolas will be in downward direction like this. So now also this is intersecting at 2 points, but the only difference is that this parabola is in the downward direction. Okay. Similarly, it can be like this. Okay. So here also d is equal to 0. And the third one is like this. Okay. So this parabola doesn't intersect the x-axis, but this is downward parabola. Okay. So this is how we decide the nature of roots of a quadratic equation by that quadratic polynomial, or by that quadratic formula, and using the discriminant. We can find out the roots of a quadratic equation using that quadratic formula. So now in general in the exam, you will get questions based on find the nature of roots of this quadratic equation, and if the roots exist, you have to find the roots of that equation. The only simple thing that you have to remember is that find out the discriminant, which is b square minus 4ac. Now if discriminant is positive, then we have distinct and real roots. D equal to 0, equal roots. D less than 0, no real roots. So this is the only way to find out the nature of roots of a quadratic equation. And in the next video, we will take some questions from the exercises of NCERT.